Chapter 2 is primarily about the history of chemistry and also looking at molecules and ions and their naming. History, first of all, we're looking at the earliest examples of chemistry, and the earliest examples back in the Iron Age would be smelting of iron, of copper, of zinc, and tin, and extracting it from the earth. Generally, these were pure metals, and not much has to be done except to purify them and get out of the other crud. Winemaking, beer making, so fermenting of juice to turn it into alcohol came along and originated in the Middle East and in Egypt. That's where the cradles of civilization were primarily. Embalming was an example of chemistry that was developed in Egypt. Greek philosophers were the next level of scientists, chemists, but they did mostly thought experiments. They really didn't do any physical experimentation. Democritus and Aristotle were the two main guys, about the same time, competing in terms of popularity, funding, all that kind of good stuff, and both of them had different ideas about what constituted matter. Aristotle came up with the idea of the four elements, and his elements were earth, water, air, and fire. He also said that matter could be divided infinitely. Democritus was his contemporary. He had a different idea about matter. His idea was that you could divide matter just so far, and then you couldn't make it any smaller. Couldn't make it any smaller than this finite size. And he had a name for this finite size. He called it an atom. The word atom comes from the Greek word a, meaning not, and tomos, meaning to cut. Not much happened between Democritus and the Dark Ages being 500 to 900, and this occurred in Europe. The only people that did any research, experimentation, exploration were the monks, because they were the only ones that could read and had any level of education. And their primary goal was trying to figure out a way to turn base metals such as lead or copper or iron into the more valuable metals such as gold. They never reached this, but they were able to discover several elements, namely mercury, antimony, and the chemists in the 1600s were the first that really were truly experimental chemists. And we start out with, in somewhat chronological order, Robert Boyle. You know him from gas laws, and he did experiments looking at the relationship between pressure and volume of a gas. Joseph Priestley was a Brit, and he discovered that oxygen was necessary for organisms to live. Lavoisier was French, and he worked during the time just up to the French Revolution. His experiments determined that matter is conserved. You cannot create or destroy matter. He also determined that oxygen is required for things to burn. Mr. Proust was a chemist, determined that chemicals combine in definite proportions, and he was a precursor of Dalton, because Dalton took this idea and expanded on it. John Dalton was another Brit, and he did a variety of things for us in terms of chemistry. He's the guy that came up with the idea of partial pressure of gases, that if you have more than one gas in a container, each gas contributes a certain amount of pressure to the system. He also combined a variety of his predecessors' theories and came up with what we consider the modern atomic theory, and we'll talk more about that when we talk about a periodic table. Guy Lussac was another Frenchman, and he experimented again with gases. These guys worked with gases, and what he determined was that when you take specific volumes of gas and combine them, you get new products in predictable proportions, predictable ratios, so combining volumes of gases. If you kept things at the same temperature, same pressure, it would always work the same way. Our final guy is Amedeo Avogadro, an Italian, and he also worked with gases. He came up with all of his ideas in working with gases, and he found that when he combined gas volumes, the volume of gas he had, if the temperatures and pressures were constant, was proportional to the number of particles that he had present in his container. And with the experiments along those lines, he came up with what we now consider the mole concept.